Good day, everyone. All right, so in this video, I want to talk about one of the past year paper, two questions from that 2019-2020 PSPM paper, and they're going to cover two topics, momentum and forces. All right, so again, this is just from 2019-2020 PSPM paper for the Malaysian matriculation certificate. Okay. So this is going to be from SP015, the first semester physics module, all right, taken by matriculation students. Okay, so let's look at the first question that we're going to talk about today. Flour at mass rate of 0.06 kilograms per second and velocity 15 meters per second is poured vertically into a bowl. If the flour comes to a rest upon hitting the bowl, calculate the average force exerted by the flour on the bowl. Okay, so as you've learned in class, that F equals to force is equals to the rate of change of momentum. Okay, if we expand that, P equals to mv, P equals to mv, what you'll have is an expansion, m dv dt, which is where you get F equals to ma plus v dm over dt, so dm dt. Now, the velocity, as mentioned in the question, is constant, and therefore this would be 0, and you're left with force equals to v dm dt, which is just the velocity multiply with the rate of change of mass, which is an information given here. Okay, so that leaves us with 15 multiplied by 0.06. Okay, so that tells us the average force that is exerted by the flour onto the bowl is going to be 0.9 Newton. Okay, so a very direct question and a very direct answer. Okay, so let's look at the second part of question 3. All right, so we're given a diagram, two balls before and after the collision, and the question goes, a 0.52 kilogram ball P moving at 0.69 meters per second collides with a stationary ball Q. So here we know Q initially is going to have 0 initial velocity. After the collision, the velocity of balls P and Q are 0.3 and 0.45 meters per second respectively, as shown in the figure. So this is the figure. Determine the mass of the ball Q. Okay, whenever we find questions like this, what we want to do, because we're talking about collision, is that we want to see if we can apply conservation of momentum. And because there's no mention of it being a elastic or inelastic collision, we can safely assume we do not need that as of this moment. Okay, so what I can say is momentum in the x direction is simply going to be mp up equals to, again, I can resolve p. I'll have mp vp and a cosine angle, so cosine 20, and then plus mq vq, again same thing, cosine 30. So that's the equation that I will get if I apply conservation of momentum in the x direction. In the y direction, what I'll have is, well, before the collision, there's no motion in the y direction, so I can immediately write down it's going to be 0 equals to mp vp sine 20 plus mq vq sine 30. Mind the direction, because vq is moving downwards in the y component, so what we'll have is not actually plus, what we'll have is minus down here. Okay, All right. So, unfortunately for this question, there are two possible outcomes, and I'll show you quickly just right here. Okay. So, if we have, all right, if we use the equation that we obtain when we consider in the x direction, so I'll quickly write it again, right? So that's going to be PUP equals to PVP cos 20 plus VQ cos 30. All right, let us just use in the x direction first. Okay, so I'm looking for MQ, so that's what I'm looking for. I know MP, I know UP, I know VP, and I know VQ. So I can go right ahead and just rearrange everything. I'll have MQ equals to, so I'll just take out MP, UP minus VP cos 20 over VQ cos 30, and I can substitute the value. So MP is going to be this one, right? So 0.52, and then UP is 0.69 minus VP. So VP is going to be 0.3, 0.3 cos 20 degrees over, again, VQ, it's going to be this one, VQ 0.45 cos 30. If you plug that into your calculator, or just, calculate it, what you'll find is that the mass of Q is going to be 0.54 kilograms. Sorry, 0.54 kilograms. Now, the problem is that if you consider the y direction instead, where the equation is 0 equals to MPVP sine 20 minus MQVQ, so sine and then sine 30. I'll just rearrange that so that I'll have MQ on the left hand side. That will give me MPVP sine 20 over VQ sine 30. I'll substitute the values at this point. 0.52 times 0.3 times sine 20 degrees, okay, over 0.45 sine 30. What you'll find is MQ will be 0.24 kilograms. All right, so two different answers depending on which equation from applying conservation of momentum. Unfortunately, there's no more information that we can utilize in the question. So I would say that both these answers are equally correct for this particular question. If you disagree, let me know in the comments below. But as of this moment, both answers, as far as I can see, are acceptable. Okay, could be just the design of the question, but that's what you've got. Okay, so moving on to the next question. All right, so a man drags a 23 kilogram suitcase with a 45 Newton force at constant speed. So this is a very important word that we're looking at, which is the constant speed, because the word constant speed tells us that our summation or our net force in the x direction is going to be 0, as shown in the figure. All right, the frictional force on the suitcase, frictional force might be moving that direction, the opposite direction, is 18 Newton. Okay, with the help of a free body diagram, calculate the coefficient of kinetic friction between the suitcase and the floor. Okay, so first things first, what we want to do is to draw a free body diagram. All right, so let me just draw the axis just so that it's easier for us to draw the free body diagram. All right, so here's our free body diagram, and we have weight going downwards, right? And then I'll have the external force, right? The external force at some angle. Let me just label that angle. And then I'll have the normal force, okay, going in the positive y direction. And of course, I'll have frictional force in the negative y direction as well. So that's my free body diagram. And then I can start writing down or at least I can apply Newton's second law. So if I were to apply Newton's second law in the x direction, right, what I'll find is F external cosine theta is going to be equal to force or frictional force. Okay, and it's from that, okay, from there we can calculate the angle. But let's just write down what happens to the Newton's second law, what we will get when we apply it in the y direction. So in the y direction, what I'll have is going to be n plus the external force multiplied by sine theta equals to W, which is just mg, right? Mg, where m is the mass of the suitcase. Okay, so I'm just going to calculate first and foremost the angle. All right, so the angle is going to come from this first equation. Okay, so calculate theta from the first equation. What I'll get is the arc cosine of F over F ext, or external force. That tells me that the angle, right, is simply going to be cos -1. Let me just substitute at this point. Okay, so force is 18. Sorry, frictional force is 18, and the external force is 45. Okay, and that gives us an answer of 66.42 degrees. So theta is going to be approximately 66.42 degrees. Okay, so now that we have our angle, we want to look at our equation for frictional force. So frictional force is defined by mu n. Because we want to look for mu, right, let me just rearrange this equation. So I'll have mu equals to F over n. I want to look for n, and I can do it by rearranging equation 2. If I rearrange equation 2, I'll have n equals to mg minus external force sine theta. Okay, so I can calculate n. So mgm is just 23, g is 9.81 minus external force 45 sine theta, which is 66.42 degrees. Okay, I can calculate now the normal force using that. Okay, so let's just key that into our calculator. So 23 times 9.81 minus 45 sine 666.42 degrees. That gives us a value of 184.39 Newton. Okay. Again, now that I have both n and f, I can calculate what our mu is going to be. So our mu is simply going to be 18 over 184.39. That leaves us with mu equals to 0.0976, right? And then again, let me just remind you that mu is dimensionless, okay? So that just leaves us with a numerical value, right, of 0.0976. And that concludes our video, okay? I'll have the next 2 or 3 questions in the next video. I'll see you there. Thank you very much. Don't forget to like, share, and subscribe. I'll see you in the next video.